Namaskar, my dear friends. Let us talk about how we can validate our low pass RC filter that is proper in our circuit. So let us say we design an RC filter, let us say R1 and C1. So with this, we will be having one particular cutoff frequency FC, which will be determined by 1 by 2 pi RC. And as you can see, by putting the value of R1 and C1, what we will get is we'll get 15.91 kilohertz. So our aim is to understand that this is a low pass filter that will be giving my cutoff frequency 3 dB here, like right, minus 3 dB will be there here. So this 3 dB will be occurring at 15.91 kilohertz. It means all the signal having frequency lower than 15.9 will be passed, right? My frequencies which is lower than FC will be allowed to pass. So let us say the input signal is 1 kilohertz. You can see 1 kilohertz is less than 15 kilohertz, 15.9 kilohertz. So what is happening? You can see the below graph. We have the input voltage PR2, right? Which is PR2 is green color. Okay. And as you can see, PR1 is the output voltage. So that output voltage is also following the input voltage. It means there is no loss at all. There is no attenuation. And if my input signal frequency increases beyond the cutoff frequency of low pass filter, the output will attenuate. It means it is not allowing. So we will verify that in our multisim simulation. Okay. So let us see what do we have is we have a low pass filter. So in this low pass filter we have the AC source of 1 kilohertz and we have R1 C1 which is going to be used to set the out like cutoff frequency of low pass filter. So if we simulate this, what is going to happen? We are going to get our Bode plot of magnitude plot and phase plot. And as you can see, I have put the cursor here at 3 dB. So here you can see minus 3 dB is almost there, Y1. Okay. And that is occurring at, uh, like 16.34 kilohertz. Actually, if I put it at, like exactly minus 3, then it will come 15.9. Okay. So yeah, 15.9 kilohertz it is occurring. All right. So this was the like AC response, or this was the AC sweep that we got it right. Now what we will do is we will set the output. We'll set the output for normal graph, right? So go to simulate AC analysis and simulation. Sorry, analyze and simulation. Go to transient and we will simulate it for let us say 5 millisecond because we have the input signal for 1 kilohertz. It means 1 millisecond will be 1 pulse, 5 millisecond will be 5 pulse. Let us run it. So as you can see, we have PR1, that is your output. Okay, this is the output. So output we are getting how much? Exactly plus minus 1 volt, that is expected. So 1 volt was input, 1 volt is coming as output. I'll just make the trace little wider. All right. And let us switch on the grid as well. Now let us put one more voltage probe here, that is my PR2. And if I run it again, my input voltage which is going to be green color. Okay. So let us make that also, like wider. You can see the input voltage is green color and the output voltage is red color. Both are matching to each other. Now this is happening because my input frequency is 1 kilohertz, which is way lesser than the cutoff frequency. Now as I increase the cutoff frequency, as I decrease the cutoff frequency, the output will start attenuating. Okay, so let me just open it to you. Here we have 100 ohm and 0.1 microfarad and the cutoff frequency was how much? 15,915 hertz, right? Now if I make it like let us say 1000 ohm, then it becomes 1.9 kilohertz, 1.59 kilohertz. So I'll just make it 1 kilo ohm. So by making 1 kilo ohm or 1000 ohm, what will happen is you can see your output has decreased, right? The red color output has decreased, attenuated, because it is very, very closer to the cutoff frequency. Okay, I'll just make this input signal little bit, thicker. Yeah, so the green color is your input and red color is your output. So red color is your output, and you can see red color output is actually attenuated because the input frequency is very, very closer to the cutoff frequency of your RC filter. Now, if you make it, let us say 10 kilo ohm, okay? So let's say I'll make it 10 kilo ohm. So in 10 kilo ohm, what will be the cutoff frequency? Tell me. Let us say I'll make it 10,000 ohm, that is 10 kilo ohm. So the cutoff frequency is 159 hertz. And in 159 hertz, you can see the input frequency is 1 kilohertz, but the cutoff frequency of RC filter is 159 hertz. It means it will not allow you to pass only, right? So let us run it and see. So you can see the red signal is almost completely attenuated. Okay, almost completely attenuated. What I mean to tell you is, let us say this is the cutoff frequency for my low pass filter, which is going to be equal to 159 hertz, and the V input having 1 kilohertz frequency. It means it will not allow that frequency to pass. Why? Because the frequency of that signal is 1 kilohertz, which is way, way more than cutoff frequency of low pass filter. So your aim would be to determine or design your RC filter in such a fashion that the frequency input is allowed to pass with the cutoff frequency that you are providing. So let us say I am going to change my input frequency to like 1 hertz. Like 1 hertz signal I am going to feed. So now my red signal will be passed very nicely. So you can see it is going to pass, but what I need to do is I need to change the simulation time, because 1 hertz is 1 second 1 pulse, right? So I'll have to go to simulate, analyze, and change it to, let us say, 5 second. So you can see my input signal and output signal both are matching. Okay, so let me remove that. So you see red signal PR1 is matching and green signal PR2 is matching. Okay, so this is the input signal, green one, and red one is output. So your aim is to understand or make sure that your cutoff frequency of the filter is way, way higher or greater than the input frequency of the signal that you are going to utilize in your circuit. So that is the best practice of having a good design, good circuit design. Okay, and quickly, if you want to have the Bode plot of this particular filter, then what you can do, go to simulate, analyze, and go to your AC sweep, change it to like decibel and all, and then run it. So you are going to have your 3 dB cutoff frequency, which is closer to 1.159 hertz, right? So what I'll do is I'll just take out this cursor and you will see this is changing to -3 dB, right? So you can see it is like -5 dB. I'll change it to -3. Okay, so -3, if you come, yeah, so you can see 160 hertz. So 160 hertz -3 dB, this is the cutoff frequency, which is 160 hertz or 159 hertz. Okay, so alright guys, hope you have a good understanding about how to simulate your circuit and how to verify your input voltage or input signal is valid or not for that particular RC filter that you are going to utilize. Same way you can utilize for your high pass filter as well. So high pass filter, what you have to do, C will come here and R will go there, and this is how you will be able to design your high pass filter circuit as well. So we'll see that in our next session. Thank you.